whenever you're ready. Let me just defocus here, make sure that, okay, you are on.
Okay, my name is Ryan Redd, and you're Myrtle Grove, can't even get that out.
Okay.
My name is Ryan Redd, and I teach at Myrtle Grove Middle School in Wilmington, North Carolina.
Okay, I'm gonna have you do it one more time.
Okay. My name is Ryan Redd, and I teach at Myrtle Grove Middle School and New Hanover County Schools in Wilmington, North Carolina.
And what did we teach today?
Today was a lesson on solving systems of equations algebraically using real-world models, or real-world problems.
Okay. You want to do that one more time?
Yes.
What did we teach today?
Today the lesson was covering the standards of 8EE, C, B, and D. Let me try that again. I am so sorry.
That's okay.
I forget the way that they use A-E-E, C, B, and C. That's what it was. Okay, got it. Okay. Today, the standards that were covered were 8EEC, B, which is solving systems of equations algebraically, so parts of that standard, and then also 8EEC, C, which is using real-world problems to solve the systems of equations.
Okay, so let's see here, going down the list. How does this lesson connect to and build on students' prior skills and knowledge? What was taught before the lesson and what will come after it?
So this lesson builds on a lot of things. So it definitely builds on their knowledge of functions, of linear functions, of solving equations, and it also builds on what came before, which was introducing systems of equations by graphing and finding that two equations can intersect on a graph and have a simultaneous answer, so an answer at the same time.
Talk about the standards or cluster targeted in the lesson. What did you do to make the lesson reflect the full intent of that standard or cluster?
So, as mentioned before, the standards that were covered were 8EECB, which reads something about solving systems of equations algebraically, but also by inspection. So I didn't do any of the inspection piece, but just algebraically using the substitution method. And then definitely the full intent of 8EEC, which is using real-world models to solve a systems of equation.
Which of the core action indicators do you think this lesson best exemplified?
So I definitely think that core action 1 was exemplified because we spent the entire lesson on one or two problems. That's focus. So it gives us so much time to dig deep and to really talk about the problems and talk about what the equations mean and talk about the variables, and to manipulate the variables to figure out the answer. It's definitely in line with coherence, which is all about building upon all of their previous understandings and linking the math to other math from prior years, but also math from what we've been doing throughout the year. And then with rigor, there was definitely some conceptual understanding here. The kids had to understand why we were writing in terms of M&Ms and what that meant, what it looks like, so it could help them see why we use the substitution method. And they were applying their knowledge to real-world situations. So it really hits on core action 1. Definitely some core action 2 here today because I had to use lots of different methods to try to make the mathematics explicit and to come out. Had to use different solution methods to help strengthen students' understanding. And I hope some 3 came out because I do know that some groups were struggling over the chicken and the duck problem, and how many ducks and what the equations look like. So I would expect that some of the indicators from core action 3 were to come out as well.
Discuss how this lesson illustrates the shifts required by the CCSS.
So as mentioned before, correction 1 definitely is used in this lesson, or that was my plan in the lesson. And the shifts, again, are the focus. We focused on 2, 3, if they even got to the last problem, high quality problems that dealt with systems of equations. And we just had that time to focus and go deep and understand the equations. Again, the coherence piece, systems of equations builds on so many prior knowledge skills or prior standards from previous grade levels. So we're still working with like independent and dependent variables and graphing and how to manipulate equations. And then also with this year, some linear functions, solving variables with equations on both sides. And then the shift of rigor, which is the most important in this lesson because it really developed their conceptual understanding piece of what a systems of equations is and why you have 2 different scenarios running simultaneously and how you can use them to solve and figure out some for unknown variables. And the application piece is we didn't just take random arbitrary equations and solve and use substitution. We actually used real-world problems that helped us solve and understand what systems of equations are.
How did you teach the content of the lesson prior to the CCSS? What is the same and what is different?
So prior to the Common Core, I probably would have started off with just the systems of equations definition, and the kids are writing it in their notebooks, and then just using random sets of equations, and this is how you do it. We're going to solve the second equation in terms of y, and then you're going to take y, whatever y equals, and plug it back into the regular equation, and then here are your coordinates. Now, after the Common Core and knowing the instructional shifts, it's okay for me to take a full day and spend an entire day on these really good, solid problems to develop their understanding of it and apply it to the real world. So going backwards, using the real world problems to help develop their understanding and even their procedural skill and fluency, that is the biggest shift for me, is giving them the hard stuff first and letting them struggle through it.
How did the students handle this lesson? Did they understand the mathematics of the lesson?
I think they did. I think that when we continue this lesson on and finish up the problems, I think that it'll make more sense when we're able to talk about the number of ducks and the number of chickens and what it means in the problem. I think that they still struggle, but it's a difficult concept for this age group to grasp at first. So I think they're going to need more problems or more opportunities to work with more high quality problems like that. But I think for the most part, they're getting the idea of systems of equations and what they are. The substitution piece, the algebraics, or solving it algebraically, I think that is still a little fuzzy, but we can reinforce that in the next few lessons.
How did you differentiate in this lesson? Did all students have the opportunity to work on grade level content?
Yeah, so all students had the opportunity to work on the grade level problems. The differentiation came in, again, in the grouping stronger kids with some weaker kids. But some kids just aren't there algebraically in their minds, so to write an equation in terms of m, that's still a hard concept for them. So to be able to model the number of bags of M&Ms as the total number of items minus the number of Hershey bars, but to be able to take out the manipulatives, so the 4 bags of the 4 bags of M&Ms and the 2 Hershey bars, and to show them that we can write the number of M&Ms based off of how many Hershey bars we take away from the total number of items. So today that was my differentiation, was some kids needed the model and some kids didn't.
Going to Core Action 3, which behaviors from Core Action 3 did the students best exemplify in the lesson?
Okay, so I'm going to take a second and look at Core Action 3. Okay. I think I am, just kidding, not ready.
Okay.
All right. I'm going to leave that down there. Okay, so were you going to read it?
I can.
Okay,
Yeah,
sorry.
Let's see. No, it's probably better for you. Which behaviors from core action 3 do the students best exemplify?
So today, the students used they were hard problems. So a lot of them, they didn't give up, but you could tell that they had reached a point of frustration where they were ready to just sort of wait on their partners to see what their partners came up with, or what their group members came up with. But to help them gain access to the problem without getting frustrated, I used the models, showing them with the bags of M&Ms and with the Hershey bars how they could come up and determine the equation in terms of M. I do think that they're getting better about explaining their thinking, but not only explaining their thinking, but also talking about each other's thinking. So I'm hoping there's a bit of that went on. I do know that they were using different tools, so some kids still were looking to graph, where a lot of kids were just using tables. So I was really pleased that even though that was a guess and check, and it really wasn't using the substitution model, but they were using a table to help understand what was going on and figuring out the answer.
Reflecting on the lesson, what worked well and what might you do differently?
So I think I'm going to need some time, more time to reflect on this, but I'm struggling with the idea of giving them the table at the very beginning of the lesson to determine the number of Hershey bars that we bought and the number of M&Ms, because they kept wanting to use the 2 and the 4 to help in the equations. So I don't know yet if that messed them up. I'll be interested to see. But I do think that they were able to take that and sort of erase it from their mind to go on and figure out the other answers. So it's still up in the air as to whether I would use that in my next lesson, or if I do this lesson again, if I would give the table first or give the table last.
And were there any surprises or unexpected student behaviors?
Yeah, actually, I was really surprised that they were able to write equations in standard form from the real-world problems without much help. I mean, some of them did need some help to begin with, but I was really surprised because they've been really good at writing equations with a linear model. And I was really surprised at their ability to just take the word problems and to write equations in standard form.
You're done.
All right.
Cool. Okay, so